G'day folks. Had a bit of a talk to the boss yesterday and he agreed to let me show you how the EDM works and what it is. It's a fairly old unit. An EDM is essentially an electrical discharge machine centre, hence the name. It allows you to burn custom profiles in things. This is a die sink EDM, so all it does is sink the die gradually into the material using low voltage DC discharge up to about 100 volts at 10 to 20 amps normal running current. Technically that is low voltage, it's not high voltage, but you still don't want to touch it, or at least touch ground and then the head while it's running. It gets a bit unpleasant, but it's a reasonably old machine. I'm going to close the back door because I'm getting a lot of glare off this. That's better. Yeah, the machine works under oil. This tank fills up with oil to a certain level, and yeah, I'll demonstrate it in a minute, but first, controls, pretty straightforward. Pump on, that's actual start cycle, start power. Night mode, it'll turn off everything when it's finished. I'm not sure what a lot of this other stuff does. Again, none of us here really know exactly how they work. That's uptime and downtime. Spark gap distance, I think. Speed. That'd probably be up and down time speed. Pulse width, like frequency, pulse frequency, current, amperage. Not sure what that is. And that's waveform, I think. Yeah, that'll be to do with DC waveform. Obviously electrode volts, electrode amps. And like that means cycle finish, collision error, that sort of thing, alarm. Yeah. Let's have a look inside. Yeah, it's all fairly old gear. It's all relay logic, a lot of relays, and a lot of power transistors. This will be the main power output stage. Pulse generation and everything will be done up here, I think. There's various large power modules and things like that. When we got it, this fan had failed, and these transistors were so hot you could cook an egg on them. It was causing stability issues, but since replacing that fan, this thing is absolute gold. This thing runs perfectly. Again, you'll have to excuse the background noise. My guys are still working at it, so you'll hear things. You'll hear the pulse MIG in the background. That's a really nice MIG to work with. DC caps and three-phase rectifier for the DC to the electrode. That's main transformer. Yeah, it's good stuff. Yeah, made in Taiwan by ARD. Very nice stuff. Nichicon caps, Toshiba semiconductors. Yeah. Should pull that out. Oh, it's screwed in. I have to undo that pinch bolt before I can pull cards out. It's a bit hard now. Alright, that's your depth adjustment. I'm not going to change it, but you've got micrometer control as well as just rough graduations. Once this goes all the way to the top, it will trigger a cutout. So if we turn him on, good. Let's say it's cut out. And let's just bring the spindle up, and it releases the alarm and everything. And yeah, reset. Spindle speed. Okay. Now the tank can obviously be opened up for working on it. That's an example of an electrode, and that's wear, electrode wear, and that's basically what it does. Just allows for a square adapter. I can't tell you what they're for, but basically they're adapting electric motors. That's all they are. They're nothing silly, nothing important. But yeah, that one's set, ready to go. That's the main drain. Close him. That's fluid level, tank level. Higher fluid level, lower level. That one, there's suction through spindle. There's a hole through the spindle back to here, so it can actually suck fluid up and keep flushing that way. And they're just main oil flushing. The dielectric unit has 2 filters and a 3-phase pump. Dielectric simply means insulator, insulating oil. That's an example of one of the filters. That's a new one. We go through one every 20 parts or so. They're only $50, $60 each, so the value for money is actually really good. Just like a giant oil filter for a car. Table has full X and Y axis control and a digital readout. The spindle doesn't have a DRO scale on it, but you don't really need it. It's got the micrometer to set your depth. And these are set to freewheel, or you can lock them in and adjust it. But at least this way, if someone bumps it, it just freewheels. So that's set. Let's turn the pump on. And wait for it to fill. Yeah, that's another electrode holder too. That's only a little 16mm one. Or even 12 actually, that's 12mm. It's raw copper. And that's what that's made out of. Now up the back, we've got suction outlets for the sprayers. That turns them on. Drain. That's fluid in from the pump. There's another little low circulation pump down there. Various bits and pieces. One-shot oiler. Give him a shot for the day. And it's back to control. I want the oil level about 10mm above, then we'll start it. Stop that.
As you can see, it's already started. Look at that.
Let's bring the level back up again, and then I'll leave it to do a full cycle. It takes about 3 to 4 hours to do it at 10 amps, 100 volts. a little bit low. Now the bandsaw's stopped. You can hear me again. In about 4 hours you get something like that. Pretty neat. Really pumping the amps into it. I don't do that for too long. About 10, 11, about 105 volts-ish. Somewhere around 105 volts. DC. It's positive to the electrode, negative to the table by the looks of it. But you can reverse that so you can EDM aluminium and other metals like that. You can actually EDM copper using a stainless electrode. If you're wondering what the smoke smells like, it smells sort of like diesel or light cutting oil. This stuff is great for lapping aluminium and drilling alley, grinding steels like surface grinding. It's a general fluid, like it's not specific for EDM. Hale's tooling sell it as EDM fluid, but their bottle even says recommended for surface grinding and drilling aluminium and that sort of thing as a general light oil. But yeah, it reminds me of diesel. Well, I hope that was interesting to everybody. It's one of the tools I get to mess around with every day. Obviously we've got lathe, another lathe, a couple of mills, 3 mills actually, pulse AC and DC welder, TIG welder, MIG welder, you name it. Eventually I'll just, I'll see if I can do a video on each of them. Thanks for watching. I guess the most important last thing to mention is the principle of the EDM, or at least how I've figured that it works. So if that's a small section of the workpiece surface, the discharge coming in will create a pit as it blows the surface away. And it'll just keep creating pits here and there, like favouring the highest point, the path of least resistance. And it'll keep creating these pits along the surface until these ridges are the highest point, then they get blown away. And it just starts overlapping the pits with the ridges and knocking it all down until even the deepest pit, 30 seconds later, it's probably at the point where this part here is actually now the highest part of it all. And it'll start knocking that off, and then that and that, and it just gradually, the electrical discharge, as current tends to do in all things, it follows the path of the least resistance. And in this case, going through the dielectric oil, using that as its sort of insulator, like a capacitor, it'll always find a place to break through, and it's almost always the highest part of the workpiece that it'll start to knock off. So it's just a controlled capacitor discharge, relatively high voltage for what I consider low voltage. 100 volts isn't high, but it's definitely enough to break through a small gap. And the kerf on that, the space between the electrode and the side of the workpiece is relatively small too. It's like 0.1 millimeters per side. So if you have to make your electrode smaller than the hole you desire to make. If I wanted a cylindrical, say a 25mm hole, I'd make the electrode 24.8 or something in that realm, and then you'd end up with a 25mm hole or thereabouts. My math might be off a little bit, but you get the idea. It's like calculating for a cut on a bandsaw or something. You've got the blade thickness to remember. That's your kerf. That's the lost material. You've got to work out what side of the cut you want it on, because if you have it on the wrong side of the line, your part's going to be one blade thickness shorter than what you wanted. The electrode design is exactly the same for an EDM. You want your electrode smaller than your desired hole that you're going to sink. So I hope that all makes sense, and hope you all enjoyed it, and thanks for watching.